Welcome to MRL. In this learning session, we'll be learning about the derivation of quadratic formula and other aspects of quadratic equation. Now, the quadratic formula is derived by knowing having the basic knowledge about the completing the squares method of solving a quadratic equation. Now, if we are given an equation ax square plus bx plus c equal to 0, then we have to find or derive the quadratic formula. Now, ax square plus bx plus c equal to 0. Now, the coefficient of x square is a. We have to make the coefficient of x square as 1, that is dividing throughout by a, we get ax square divided by a, bx divided by a, and c by a equal to 0, and therefore we get x square plus b by x plus c by a equal to 0, where the coefficient of x square is 1. Now, taking the first two terms, we have to convert it into a square form. So therefore we have to find out the third term. To find out the third term, take the coefficient of x, b by a, divide it by 2 and square it, add and subtract, so that the value of the equation does not change. So we have x square plus b by x plus b by 2 a whole to square minus b by 2 whole to square plus c by a equal to 0. That means from two terms I have converted into three terms, and these three terms are the expansion of a plus b whole to square. So a is x here and b is b by 2a. Therefore a plus b whole to square gives the expansion of a plus b by 2, that is x plus b by 2a whole to square, is x square plus b by x plus b by 2 whole to square, and that is what the completion of the squares method. Now these two are taken onto the right side, that is minus b by 2a whole to square plus c by a becomes b by 2 whole to square minus c by a, and then simplifying this we get x plus b by 2a is equal to b square minus 4ac upon 4a square. Now taking the square root on both the sides, by taking the square root here, we get x plus b by 2a is equal to plus minus root of b square minus 4ac upon 4a square, and taking the square root of the numerator, we get plus minus root of b square minus 4ac, and the denominator square root will be 2a. Therefore x is equal to minus b by 2a. Taking minus b by 2a to the RHS, we get minus b by 2a plus minus root of b square minus 4ac upon 2a, that is equal to minus b plus minus root of b square minus 4ac, and the LCM of the denominators is 2a. So remember that. Therefore x is equal to minus b plus minus root of b square minus 4ac upon 2a is the required quadratic formula. Okay, remember this. So this is the derivation of quadratic formula. Now let us understand how to use this quadratic formula to find the roots of a given quadratic equation. So here we have been given an equation 2x square minus 7x plus 3 equal to 0. We have to find the roots of this, and the method we are going to use is the quadratic formula method. Now we know the quadratic formula is x is equal to minus b plus minus root of b square minus 4ac upon 2a. So find out the values of a, b, c first. Now here a is equal to 2, b is equal to minus 7, and c is equal to 3. Now substitute these values in this. That means wherever b is there, put minus 7, wherever b is there, put minus 7, wherever a is there, put a is equal to 2, that is 4 into 2, and c is 3. Simplify, that is the numerator and the denominator, we get minus into minus is 7 plus minus root of 49 minus 24 divided by 4, 7 plus minus root of 25 divided by 4. Therefore we have x is equal to 7 plus minus 5 by 4, that is x is equal to 7 plus 5 by 4, x is equal to 7 minus 5 by 4, x is equal to 12 by 4, x is equal to 3, and x is equal to 7 minus 5 is 2, divided by 4 is half, therefore x is equal to half. Therefore the roots of this equation is x is equal to 3 and x is equal to half. So therefore quadratic formula is a very easy and convenient method of finding out the roots of a quadratic equation. Remember that. Now the graphical method of solving quadratic equation. Now for this we have to draw the graph of the quadratic equation, and the graph of a quadratic equation is a parabola. So we have to use a suitable scale and draw a graph. We get a parabola. Now draw the graph and locate the points of intersection. The graph, which is a parabola, cuts the x-axis at different points, and locate the points where the graph cuts the x-axis. The x coordinates of the points of intersection of the graph on x-axis gives us the roots of quadratic equation. And in this case, if you see, the graph cuts the x-axis in point A and B. The coordinates of point A are alpha 0, B are beta 0, alpha and beta are the roots of the quadratic equation, and that is what is the graphical method of solving quadratic equation. Remember that. Now the next important study is the relation between the roots and the coefficients of quadratic equation. I think we have learned this. We already learned this in polynomials, quadratic polynomials. There the quadratic polynomial was ax square plus bx plus c, and the zeros were alpha and beta. So with that knowledge we can also establish the relation between the roots and the coefficients of quadratic equation. So alpha plus beta is equal to minus b by a. If alpha plus beta are the zeros of a quadratic polynomial, then alpha plus beta is equal to minus b by a, which we have already learned. So also it is same for the roots, because the roots of a quadratic equation are the zeros of a quadratic polynomial. Therefore the sum of the roots of a quadratic equation is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. That means sum of the roots is equal to minus coefficient of x divided by coefficient of x square, and so also the product of the roots alpha beta is equal to c by a, where c is the constant and a is coefficient of x square. So therefore remember, the same relations hold for the zeros of a quadratic polynomial, and also the same relations hold for the roots of a quadratic equation. The zeros of quadratic polynomial are the roots of quadratic equation. Therefore alpha plus beta is equal to minus b by a is the same for both the polynomial, quadratic polynomial and quadratic equation, and so also alpha beta is equal to c by a is same for a quadratic polynomial and quadratic equation. Remember that. Now to form a quadratic equation when the roots are given, now we are given the roots alpha and beta, we have to form a quadratic equation. Already we have learned this in polynomials. If we know the zeros, we can form a quadratic polynomial. So also here the required quadratic equation will be x square minus alpha plus beta into x plus alpha beta equal to 0. Now if you remember, in quadratic polynomial we can find the quadratic polynomial knowing alpha beta, the zeros alpha and beta, and the formula was x square minus alpha plus beta x plus alpha beta, but only the difference is here it is equated to 0. Therefore x square minus sum of roots into x plus product of roots is equal to 0 is the required relation or formula to find out the quadratic equation when the roots alpha and beta are given to us. So please remember, the same relation holds good for both the polynomial, quadratic polynomial and quadratic equation. Here the zeros become the roots. Okay, remember that. Now to know the nature of roots of quadratic equation, this is very important to understand the nature of roots of a quadratic equation. Now we have to consider a few examples to understand the nature of roots, and we'll also understand what we mean by nature of roots. Now let us take one by one 2 or 3 examples to understand this. Now let us take the equation x square minus 2x plus 1 equal to 0. By using the quadratic formula, let us find the roots of this. Now we know that the quadratic formula is x is equal to minus b plus minus root of b square minus 4ac upon 2a, and here a is equal to 1, b is equal to minus 2 and c is equal to 1. Substituting these values in this quadratic formula, and simplifying this, we get x is equal to 1 and x is equal to 1. Here we find the roots are 1 and 1. That means that is alpha and beta are both 1. That means the roots are real and equal. So this is one nature of roots. So the nature of roots, one important nature what we understand here is a quadratic quadratic equation can have the roots which are real and also equal. So that is first nature. Now let us understand the second nature. Now take the equation x square minus 2x minus 3 equal to 0. I have just taken one example here, x square minus 2x minus 3 equal to 0. Let us find the roots of this using quadratic formula. We know the quadratic formula x is equal to minus b plus minus root of b square minus 4ac upon 2a. Now a is equal to 1 here, b is equal to minus 2 and c is equal to minus 3. Substitute these values in the equation, then simplify. When we substitute and simplify, we find that x is equal to 3 and x is equal to minus 1. Here the roots are definitely real, but they are not same, they are distinct. Therefore we say the nature of roots are real and distinct in the second case here. And now let us take the third important example and the third case rather. Now equation is x square minus 2x plus 3 equal to 0. Find the roots of this using the quadratic formula. X is equal to minus b plus minus root of b square minus 4ac upon 2a. Here a is equal to 1, b is equal to minus 2 and c is equal to 3. Substitute these values in the formula and simplify it to get the values of x as 1 plus of minus root of minus 2. That is x is equal to 1 plus root of minus 2 and x is equal to 1 minus root of minus 2. Now the roots are not real here. The roots are not existing. They are not real. The roots are not real. Therefore the roots do not exist. So this is the third important nature of roots. So by these 3 examples, what we have understood is, the conclusion is, from the above examples we can conclude that a quadratic equation can have different types of roots which are called as nature of roots. The nature of roots are real and equal, roots are real and distinct, roots are imaginary. So this is what is called as the nature of roots. We can know the nature of roots by solving the quadratic equation by one of the solving methods discussed. We can adopt any one of the methods and find out the roots and understand the nature of roots. but using a quadratic formula method is a good method of finding out the roots and to understand the nature of roots. In the next session we will be learning a very important what you call aspect of quadratic equation, that is the discriminant, and also how to identify the nature of roots. Okay, please go through all these basics of this part, and then in the next part we'll see the other aspects of the quadratic equation.